Okay, so now without more ado, it's time to welcome our speaker for today, Professor Philip Clayton, who is the Ingraham Professor in the Claremont School of Theology, and he's also Professor of Philosophy and Religion in the Claremont Graduate University. And Philip's currently on sabbatical here in Cambridge. As many here will know, he's at the Divinity faculty, and we're particularly pleased that he's also a visiting fellow here at St Edmund's College. And as I'm sure you all know, Philip has written very widely on this area of science and religion, has lectured very widely, and so we're delighted that he's here to give our seminar today. And his topic is Concepts of Emergence in Science and Religion.
Thank you, Dennis. And thank you for the invitation to address this group today. Concepts of emergence in science and religion. Sounds like you'll be offered a typology. That I'll stand back in careful neutrality and describe the way in which emergence is used in some of the scientific disciplines, in the philosophy of science, and in discussions of religion. But I think it would be much more interesting if I left the claim, the pretense to neutrality and objectivity, and argued a thesis. It's much more risky, but more interesting to you. So take out your pens and pencils, and I shall try to make a case today. I'll begin by locating myself, because making a case always implies a location, right? I locate myself as a Christian theist, and as one who's extremely interested in the sciences, who believes not only that it's interesting for me to grapple with results from the sciences and their implications, but that it's also a mandate, that it is required for rational belief that I hold a position which is consistent with the sciences. Emergence will represent a particular way that I attempt to meet that obligation. Dennis, we're out of chairs. I'm not sure what we should do. Please come on in.
It's okay.
There we go. Right. Along with talking about emergence, I would also like to demonstrate a mode of interaction between religious reflection and scientific results. So that will make the talk a bit more demanding, because I hope to offer to you not only a particular argument at one level, but what I will hold up as a model for this sort of argumentation, a methodology, as it were, on another level. And it's the talk will proceed on those two levels at the same time. I hope that won't be too demanding, but it might be more interesting. And that means I can be doubly criticized. First, for the specific argument I put forward, and secondly, for the model that I put forward, abstracted from the particular claims I make about emergence theory. Right? So, let's think about the model for a moment. To hold a religious commitment, in my case as a Christian theist, is to hold certain belief commitments. Those belief commitments are consonant with or coherent with other claims or items of knowledge, and potentially they conflict with other claims that one might encounter. Let's think of a case of conflict. Now, I take it, for example, that as a Christian theist, I'm committed to the position that human beings are rational moral agents. That is, that we act in cognizance of certain moral obligations, and that we know ourselves sometimes to fulfill those and sometimes not. Right? Now, if it turned out, I think this is a counterfactual proposition, but it could be true. If it turned out that humans aren't in fact rational moral agents, but in fact we are the product of complex biochemical processes, that sense of agency that each of us has that brought you, let's say, to this room today, is an illusion, and that we are just, as it were, mechanical systems, biochemical systems, right? Then, the sort of agency required by my Christian theism would be false. And I would call that an instance of incompatibility, incompatible beliefs. And I would be in a position where I would need to withdraw one belief or the other, that is, to say, well, the science is wrong, which X hypothesis here is a difficult hypothesis, or that the theism is wrong, and I should change my religious beliefs. Now, I can imagine you say, well, no, there's a third possibility as well, right? Credo ut absurdum. I could become a Kierkegaardian, I could say, no, my religious faith is a matter of complete rational absurdity, and that's what leads to this infinite passionate inwardness that constitutes my religious life. And I acknowledge that that's a possibility. So what we should say at the outset in this methodological principle is that in cases of conflict between religious belief and science, the religious believer might always retreat from the playing field of rationality and say that religious belief is a matter of interiority, of inner conviction, of aesthetic sense or something, with no rational claims whatsoever. I can't foreclose that possibility. But that strikes me as a very expensive move for religious believers to have to make. And so it seems to me that we have every reason first to go as far as we possibly can in making rational connections, in trying to show, in this case, that the results of the sciences are compatible with the sorts of beliefs that we hold. Right? And that's what I aim to do as an illustration in today's discussion of emergence. We're in a stronger position if we can establish a coherence between our religious beliefs and the results of science. Now, how strong can that coherence be? What should we expect from the discussion of the sciences? For example, should we expect that we might be able to prove religious beliefs based on scientific results? This obviously was a major tradition in Western intellectual history. Theistic proofs are a major locus in philosophical and theological debate. The question has received much attention today because of a movement, strong in the United States, but apparently also making itself felt here, called intelligent design. Have any of you heard of this particular school of thought? It seems to have brought back the idea of a theistic proof right into the center of the debate today. Because the claim of Michael Behe and William Dembski and others is that we find results in the natural sciences which cannot be proven by any form of scientific research, which are incompatible with any form of naturalism, and which demand the hypothesis of an intelligent designer. What's really fascinating about the claim is that they claim that this is a scientific conclusion. We are scientifically led to postulate an intelligent designer, either because of irreducible complexity in the biosphere, say the development of hemoglobin in the bloodstream, said Behe in a book called Darwin's Black Box, or because of the astronomical implausibility of a universe arising of the sort that ours is from chance. That only an intelligent designer is a plausible hypothesis to explain this universe, right? Though I cannot address that today, I want to distinguish my position and my method as sharply as possible from that intelligent design movement, which it seems to me makes the error of introducing theistic language as a scientific hypothesis and asking it to do scientific work. I will try to make a case for theism, but I will make that case in philosophical or metaphysical terms. And I want to distinguish the sort of case I'll make today as sharply as possible from that quasi-scientific or pseudo-scientific approach of the intelligent design theorist. One way to make this case more clearly is to insist that results from the sciences constrain religious and theological reflection, but are not sufficient for religious or theological reflection. Scientific results are a necessary component. We build on them in some sense, but the scientific results aren't sufficient for the religious conclusions. Emergence is interesting for those of us in the religion science discussion for three reasons. It's receiving much attention from scientists and philosophers of science today. So it has a sort of scientific valence. It challenges the sort of reduction I mentioned a few minutes ago. It stands opposed to the claim, for example, that the human is nothing but biochemical processes. And it also raises a question which is fascinating for our entire field, and it's this question: how far can one actually go in moving through scientific knowledge and the interpretation of science toward religious questions? Is there some place at which that arrow, as it were, that we might derive from scientific inquiry hits a limit, where one has to move to a different sort of conceptualization, a different sort of argumentation or experience altogether? So it raises that question of a boundary or border, doesn't it, that is introduced into the scientific or philosophical reflection. And I hope that we can keep all three of those before us today. Right, so let me begin by giving you an overview. I want to talk about emergence in physics and biology. Then I'd like to talk about emergence in the human person. And then I'd like to talk precisely about that boundary where it seems to me that we have to introduce another sort of reflection or argumentation altogether. And then lastly, I'd like to talk about theological results or consequences. All right? Let's talk first about emergence theory in physics and biology. Emergence stems out of the discussion of complexity or complex systems. It's concerned with the principles of self-organization within the natural world, the formation and propagation of complex systems, natural systems. So Jean-Marie Lane, for example, says, complexity theory asks, what are the steps and the processes that lead from the elementary particle to the thinking organism, which is at present the organism of highest complexity? Note that complexity is a systematic feature. It involves the interaction between many different components, correlations, couplings, and feedback mechanisms between components of a natural system. In many cases, these form into a sort of hierarchy, so that we're talking about the way in which the whole of the system constrains the motion or the behavior of the parts. So that gives you a multiple level form of analysis, which is basic to many forms of complexity theory. Again, Jean-Marie Lane says, emergent complexity spans the entire spectrum of cosmic history, from divided to condensed matter, then to organized and adaptive matter, on to living matter and thinking matter, up the ladder of complexity. And all of that falls within this area of complexity studies. How could one characterize emergence theory? Let me try, for the sake of our brief time today, to reduce it to just three theses. Right? First, emergence theory is the claim that empirical reality divides naturally into multiple levels. William Wimsatt has argued this in detail in The Philosophy of Science. New levels evolve through the course of natural history. As the natural world becomes more complex, it forms new wholes. Those new wholes then serve as parts in the formation of new natural wholes, and so forth. Second, these wholes are more than the sum of their parts. They can't be comprehended only in terms of the logic or the explanatory categories of the parts. That means that natural science requires us to formulate disciplines at the level of a new emergent whole, which are capable of formulating the sorts of structures and functions and interactions of those emergent wholes. That's the second point. And third, these emergent wholes manifest their own kinds of causal interaction. This third premise of emergent causality contrasts with the claim that all causality is microphysical causality. Carl Gillette, for example, the famous philosopher of science, but also Jaegwon Kim, the philosopher of mind, has argued that physicalism, or science in general, entails the belief that all causality is ultimately microphysical causality. It's only a limitation on our knowledge that we speak of other forms of causal activity. Emergence theory stands opposed to that claim and makes the claim that the world evidences causal interactions at these multiple levels, that the causal interactions are irreducible, that they can't just be parsed in terms of the lower levels. For example, there are irreducibly biological interactions. If we had time, I would talk about some of the steps of this process. Wojciech Zurek, for example, argues that classical physics is emergent from quantum physics. If the string theorists are right, quantum physics is itself emergent a phenomenon from, say, string theory or game theory. Right? But we'll let that one pass. We heard something about string theory last week, and the skeptical tones are probably still ringing in your ears from John Polkinghorne's comments. But let's talk for a little bit about condensed matter physics, since a recent Nobel Prize winner in physics, Robert Laughlin, has just published a book on emergence based on his Nobel Prize winning work on the fractional quantum Hall effect, a book called A Different Universe. Laughlin claims, quote, "The fractional quantum Hall effect reveals that ostensibly indivisible quanta, in this case the electron charge E, can be broken into pieces through self-organization of phases. The fundamental things, in other words, are not necessarily fundamental." And in this really fascinating book, he challenges the traditional view of physics as inaccurate to the actual data in various fields, but in particular, in his case, in solid-state physics. Some of his examples, for example, include superconductivity, of course, the quantum Hall effect, phase transitions, crystallization phenomena, collective instabilities, and hydrodynamics. And he wants to argue that in all of these cases, the standard picture is flawed, and we need to think in these emergentist terms. What's really interesting is he doesn't say that the reductionist goal is just false. He writes in the preface to the book, "All physicists are reductionists at heart, myself included. I do not wish to impugn reductionism so much as to establish its proper place in the grand scheme of things." And it's that form of emergence that I'd like to hold up before you. One finds in certain publications a sort of glorying in emergent wholes, and one looks for them wherever one can find them. Maybe the Earth is an emergent whole. Maybe the universe is an emergent whole. I read a book last week that told me that the sun has consciousness, and therefore we should imagine solar systems and galaxies, and finally the universe as a whole, as having its own center of consciousness. Right? It seems to me what that sort of unrestrained emergentism requires is a little bit more of that reductionism that Robert Laughlin introduces, to be a reductionist at heart. William Newsom at Stanford, who works with rhesus monkeys, says that every scientist in the laboratory is a reductionist. And we do standard reductionist science. That's what we do. And yet Bill Newsom is at the same time an emergentist with regard to the entire structure of the natural world. And I would rather have you try to hold those two things together in the proper tension than to go running off with emergence as if it's a new science altogether. There are unfortunately too many books that tell us, emergence, the new science. Well, science is science in one sense, isn't it? It's just that our understanding of the natural world may be different as a result. Let me give you one more quote from Laughlin's book before we move on to biology. This is a very controversial passage. I'll read it slowly. "Newton's legendary laws have turned out to be emergent. They are not fundamental at all, but a consequence of the aggregation of quantum matter into macroscopic fluids and solids, a collective organizational phenomenon. Astonishing as it may seem, many physicists remain in denial. To this day, they organize conferences on the subject and routinely speak about Newton's laws being an approximation for quantum mechanics, valid where the system size is large, even though no legitimate approximation scheme has ever been found. The requirement that Newton's laws emerge in the macroscopic limit was christened the principle of correspondence in the early days. But the correspondence principle remains mathematically unprovable." And he concludes, "I am increasingly persuaded that all physical law that we know about has collective origins, not just some of it. In other words, the distinction between fundamental laws and the laws descending from them is a myth, as is the idea of mastery of the universe through mathematics alone." There's a claim for emergence at the level of solid-state physics. What about emergence in biology? In some senses, the argument is naturally more plausible and easy to make, it seems to me, in the biological sphere. Because here we have a process of the continual emergence of new forms, new structures, new functions, and therefore new ecosystems, that is, new systems of an interrelationship between organisms. Emergence, again, is not an unrestrained holism. We'll call it California holism, right? A sort of holism without limit. It rather, if it's going to be science, is a story of the interaction of continuity over evolutionary change and discontinuity. Continuity back, say, to common genetic structure, and discontinuous stages of development. It seems in some ways more clear as you move on to complex organisms, to populations, and to primate behavior. It seems clear that new entities, new types of explanation, and new types of interaction emerge. And yet, it seems to me that one finds already at the earliest stages of life, of the evolution of life, a sort of emergence. So Stuart Kaufman, the emergence theorist from, formerly from the Santa Fe Institute, he's now in Canada, and I have just published a paper on the emergence of cellular agency. And we've tried to argue that in at least 5 respects, the first self-reproducing cell already evidences properties that could not be calculated in terms of its biochemical properties. That as a self-reproducing cell, and a unit on which natural selection can operate, it already has features that could not be parsed in terms of physics. That biology, the biology of the evolutionary process, needs laws of its own, principles of describing regularities of its own, which could not, even in principle, be deduced from or inferred from physical laws. That's a claim we'd have to parse in more detail. But that's an argument already at an imagined first level of a biological unit on which principles of natural selection could operate. Okay, we could move through more complex organisms. We could talk about zoology. We could talk about population dynamics, the emergence of central nervous system, well, first nerve cells, central nervous system, and finally complex organisms like the higher primates. That will lead us then in a moment to the question of mentality and whether we can construe conscious life as emergent. But let me pause for a moment and try to sort out 3 different ways in which this term emergence is being used, both in my presentation and in the literature. First, as science, it's the study of complex systems. It's attempting to find something scientifically significant that is shared in common, replicable, across different forms of complex systems. To define complex systems in a rigorous and empirical manner, and to find common principles that might be shared among them. Those of you who know the science know that that already is a difficult task. And one should not run too quickly to the eagle and say, I've done it, right, until one has been able to do the science. That's a difficult task. And one remembers only too well the claims made on behalf of systems theory earlier, the claims made on behalf of Shannon information, other attempts to quantify the growth of information or complexity. That is a difficult task, right? That's an ongoing task. Second, emergence is a position in the philosophy of science which attempts to give a justification for distinct levels of inquiry. That is, distinct scientific disciplines, not as the sign of failure, but rather as an appropriate way to study the complexity of the natural world in the different levels at which it manifests. Right? So the distinctness of the special sciences is a separate premise, and one to be distinguished from this first task within complexity theory. Third, it's a prediction. And this one is blatantly philosophical. Emergence theory is the prediction that these distinct levels are permanent. They're not just a product of our current limitation of knowledge. And they won't be replaced someday by a single scientific framework studying microphysical causes in all their various manifestations. It's an empirical thesis because it's a claim that the empirical world manifests at these distinct levels of organization. Of course, there are interrelationships between them, but what it's most opposed to is what was known as the unity of science movement, which dominated, say, the 1940s and 50s, which argued that finally we'll achieve a unity of science in which all the sciences can be expressed in terms of certain fundamental laws, covering laws, and laws reducing other levels to the single one. What I'd like to argue is that these three theses represent not an incursion of metaphysics into otherwise good science, but rather the opposite, a sort of unrelenting empiricism, what some scientists have called a natural piety to the way that the world actually manifests itself. The claim of emergence theorists is that the dogmatism lies on the other side. The dogmatism lies on the side of those who would claim that the only correct model for scientific research is the final reduction. According to the emergentist view, we're not merely biologists simplicator, much less geneticists only. We're cytologists, systems biologists, botanists, zoologists, primatologists. We're not only molecular biologists and geneticists, but also population biologists and ecosystem theorists. We're interested in the large and the complex as much as in the small, in emergent phenomena as well as in reducible phenomena. That would be a statement of the position. I would like to claim that this is actually closer to the mindset of Darwin's own work than some of his most vocal supporters in recent years at a small university somewhat to the southwest of us. Think, for example, of Darwin's famous description of the riverbank in that closing paragraph of The Origin of Species. Quote, "It's interesting to contemplate an entangled bank, clothed with many plants of many kinds, with birds singing on the bushes, with various insects flitting about, and with worms crawling through the damp earth, and to reflect that these elaborately constructed forms, so different from each other in so complex a manner, have all been produced by laws acting around us. There is grandeur in this view of life, with its several powers, having originally breathed into a few forms or into one. And that, whilst this planet has gone on cycling on according to the fixed law of gravity, from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved." It seems to me that's an emergentist vision, sharply to be distinguished from certain forms that theory of biology and theory of evolution have taken in more recent years. All right, I need to be brief now that I come to the hardest question of all, the nature of man and woman, the emergence of persons. Let me just say what would follow from the position I've taken so far. First of all, one looks for as much common ground as we can possibly find between humans and other animals, for that's what good science requires. We work from the common structure and chemical composition of DNA, from common mechanisms of cell communication and regeneration, from studies of the development of the central nervous system and the brain across the biosphere. We can learn from countless areas of biological study something about human nature. Nerve cell similarities allow us to learn from electrochemical responses in electric eels. Brain plasticity is similar in frogs and in humans. Perhaps you've heard of the Harvard experiments where an additional leg was grafted onto a frog, and in one case a third eye. You can see some of these publications. They're sort of gruesome, actually. Right? But what they did then was to dissect the brains and to find the extent to which brain regions, which in the frogs formerly had vastly different functions, were taken over to help run these new extensions, either leg or eye or what have you. The incredible brain plasticity that we found in this simple frog brain gives us some sense of the level of brain plasticity in human beings. I'm sure you've read about the study of mirror cells in chimps, which were immediately applied to ontogenesis of human children. Bill Newsom, who I mentioned before at Stanford, studies visual processes in the macaque and rhesus monkeys, and from that we learn about the social nature of perception in human beings as well. There are these fascinating studies of other minds, the theory of other minds, primitive theory of other minds, in monkeys. You know, the case where the monkey can see that food was placed behind a protective wall when the larger monkey wasn't watching, and then the larger monkey is brought back in. If he knows that the monkey didn't see it being put there, he'll go and get the food. But if the larger monkey was watching all the time, he won't go and get it. And I think clearly those experiments show that the monkey has a theory of other minds. That is, he knows what the larger monkey could have seen or couldn't have seen, and therefore what he's safe to do or not do. And that experiment has been replicated in many different forms since that time. Or the studies by Frans de Waal of reconciling behaviors in the great apes. And from those, I think we learned something fundamental about human sociology. Right? That's part of the Emergentist program, to look for every one of those connections that one can find. But it also argues that those studies don't tell us everything of the nature of the human being. There are differences involved in our own development that require us to study the human being in a manner different from how we would study other animals. Terry Deacon describes it brilliantly in this 1997 book, The Symbolic Species, which I highly recommend. It's in the school of coevolution, going back through William Durham to the 1930s. The argument that the development of language use in human beings co-evolved with the development of this more complex brain, the frontal cortex, and a massively more complex structuring of the frontal cortex. And that the only way to understand these scientifically is to look at the development of the language and the development of the brain side by side, because they exist in a codependent relationship. But that makes the development of culture, for after all that's what language use involves, irreducible in the comprehension of the human being. It stands in tension, for example, with the sociobiology project first launched by E.O. Wilson about 1975. Here's the thesis. Quantitative increases in complexity eventually lead to qualitative differences. Quantitative increases in complexity eventually, in many cases, lead to qualitative differences. And where the qualitative differences occur, they require explanation at that level of the phenomena and not at the lower level. A reduction is tremendous when you can achieve it, but we make the prediction that that sort of reduction will not finally occur because it's not the nature of the reality that we find manifested empirically around us. And we can do this in great detail. The level of culture and language and thought is a new emergent level. It continually depends on the lower levels, and yet it involves the manifestation of something more. Dead speakers don't give lectures, though there are dead lectures, right? And a massive stroke occurring in my brain at this moment would cause the talk to be much less clear than I hope it otherwise is. And if we had served alcohol instead of coffee, that chemical difference in you and in me would have led to a very different session. Perhaps a more pleasurable one, for all I know, right? But it would have had certain differences which are manifest. Nonetheless, this talk and your comprehension and your thoughts are not merely functions of the chemical or electrochemical state of your brain. In understanding our interactions, we need not only a knowledge of those lower levels, but a knowledge of the entire social systems of which you are the product. Your birth language, we were talking about that earlier on, your family of origin, your friends, your education, your fundamental moral and religious commitments as well. All of those go into a comprehension of what's occurring in this room at this moment. And you can imagine how that would lead to a study of the human being which draws from the biological analogies wherever they're possible, and yet at the same time fights for the distinctness of the social sciences as irreducible components of our knowledge of the person. Psychology, sociology, anthropology, archaeology, and so forth. Science leads us, a study of the empirical world leads us to speak of mental properties of that being, that biosocial, psychological being that you are, and the causal efficacy of those mental properties. I think a study of the natural world leads us to believe that the mental properties are causally efficacious in the world. Science will never justify, in my view, an assertion that we have souls or that we are composed of spiritual substances of some sort. That goes outside of the sort of domain that science would have an ability to verify. But the causal efficacy of mental properties, of cultural contexts, does seem to be a manifest property of the natural world. I would go one step further, and that is to say that though science doesn't directly understand a sort of person substance, it does allow us to understand the agency that is involved in your having the sort of mental properties that you do. That is not just you are not just a human bundle of mental properties, ideas and impressions. You're also an agent who produces such properties in certain more or less predictable manners. And that's a part of given of the natural world. All right, let me close now with moving from the emergence theory to its implications for religion and for theology. And then let's move on to discussion. Part of what's manifested in the human person are spiritual beliefs, religious beliefs, beliefs about forms of reality beyond the natural. We are, as the history of the human species shows, in many ways, homo religiosus. And that tendency to form religious beliefs and for them to play an important part in the thought and behavior of human beings is a natural given within the world. But that fact raises an unavoidable metaphysical question. Are those beliefs true or are they false? The one position I want to resist is the claim, most made in recent years perhaps most famously by Pascal Boyer, that science requires us to hold that the beliefs themselves are false. They have a functional role in natural human interaction, but the content of the beliefs has to be at best bracketed and, for him, de facto reduced to the level of biosocial interaction that we live in. Like it or not, it seems to me, the manifestation of culture and its inclusion of clear religious beliefs across cultures and across time forces us to ask the question, so, are those beliefs true, or are they beliefs that should be, are false, are actually false? How can one debate those questions, right? On the one hand, we have, say, in Peter Berger's claim, the claim that the religious is constitutive and in some sense true. Peter Berger says in that famous book, A Sacred Canopy, every society is, in the last resort, persons banded together in the face of death. The power of religion depends, in the last resort, upon the credibility of the banners it puts in the hands of men and women as they stand before death, or more accurately, as they walk inevitably toward it. Right? The truth of the beliefs that we hold finally about the nature of the universe. You can contrast that with the famous claims of Jacques Monod, that it's all a matter of chance, or that classic quote by Friedrich Nietzsche as expressing the opposing position. Once upon a time, in a distant corner of the universe, with its countless flickering solar systems, there was a planet. And on this planet, some intelligent animals discovered knowledge. It was the most noble and most mendacious minute in the history of the universe, but only a minute. After nature had breathed a few times, their star burned out, and the intelligent animals had to die. Do you see the sharp contrast between these two views of the world? And I find no way to avoid the question, so which of them is true? I also find no requirement within a study of the natural world, at least as I've described it today, to say that science excludes such questions. Science opens up a vista of questions, a playing field, which I think we're encouraged as human agents to move on to. The position of, and then we could do the debate. I think for the sake of the discussion, I'll skip trying to make the case for the particular theistic response. And let me just here close by mentioning some of the options that become a part of this debate that I think we now need to engage in. One could hold that there is another realm that lies behind the natural realm, but that it is ruled by an impersonal moral law, an impersonal sort of spiritual law that defines this realm. That would be the belief in karma. There is some sort of law-like force that leads to certain behaviors in the world. That law is irreducible to lower levels. Second, one could hold that there's one spirit of which all things are parts, but ultimately their distinctions are covered over within the one overarching spirit, or Brahman, saying the philosophy of Shankara most clearly in the Advaita Vedanta tradition. One can hold that things and persons have distinct entities, and yet at the same time we live and move and have our being within a one spiritual reality, which is has the properties that we have, say personhood, rationality, consciousness, and infinitely more. This is the position of panentheism, which I hold, that all things are contained within the divine, but God is also more than the world. God has the highest properties that we have, and infinitely more. God is supra-personal, or three-personal, tri-personal. One could hold a view of classical theism, that God created a world outside God's self, according creation out of nothing, according to certain goals and principles, and that God intervenes in that world to lead it toward a certain outcome, or doesn't intervene. John was so careful to avoid that word 2 weeks ago. One could hold, for example, that the emergence gives us the sense of how we should do our metaphysics, as emergent properties are manifested at separate levels. Perhaps beyond the level of the human is another emergent world. Maybe the natural world is gradually taking on the attribute of divinity. It's, as Samuel Alexander said in the Gifford Lectures of 1918, the world is deizing itself. The world is deizing itself gradually, taking on spiritual properties. But there is in the end just the one world, not a separate God. And of course you could be skeptics and say, though there seems to be an arrow pointing further, there's nothing more that can be said. And at this point we fall into silence, reverent or otherwise. The position of apophatic theology, the via negativa of the perennial philosophy. There's something more, but I know not what. So, in conclusion, we've looked at a particular school that's received a lot of attention within the sciences and the philosophy of science. I've tried to sketch that position, and then at the same time I've tried to give you some indication of what impact it might have for those of us who are interested not only in religious phenomena to be understood as social scientists might study them, but also in the question of religious truth claims. For those of us who are located in a religious tradition, that sort of reflection seems particularly important, and indeed I've tried to show indispensable. Thanks very much.
Thank you very much, indeed, Philip. We've got 12 minutes until 2 o'clock, so fire away, please, for questions. It's going to kick off. Yes.
Something towards the end where you talked about the other realm being governed by a law of karma, you're saying, but I'm saying that the law of karma is operating in this world, and the law that operates in that realm is the law of love. Okay?
Right, I actually meant to introduce just the karma principle without all of the metaphysics that one finds in the Indian traditions behind it. So you might just say that in addition to physical laws and biological laws and generalizations across human behavior, there's also a karmic law that functions in this world. So in that sense, we're not disagreeing with each other, right? And what if one held that and nothing more? What if one said, oh, I don't know about Brahman and these other things. All I know is that there is this other principle, spiritual law, at work in this world. That was the position that I meant to put on the table first.
Many thanks for the talk. I wondered about the step that there still seems to me between recognising that wholes constrain their parts and that we can't reduce complex systems down to simple things, and the step that still seems to be bigger and possibly of a different order to phenomenal consciousness, where I have a first-person view, because all of the other sort of systems which I recognise in science as suggesting some sort of emergent property are still sort of things in space and time with an objective third-personal description that a scientist can make. But yeah, I'm making that from my first-personal sort of irreducibly mental thing. And it doesn't look to me that any amount of complexity is giving me what I want, the step from the third person to the first. So do you think that emergence really has much to say? I mean, I know it's brought out here, but it doesn't look to me to be casting light on this particular problem to any great degree.
That's a brilliant question. It's a brilliant question, one of the really important dimensions raised by this whole emergence discussion. It's the one that I've been preoccupied with over the last 6 years while I was working on the book Mind and Emergence. What you said pushes us toward dualism. We want to say, I mean, we're inclined to say when we hear that, well, look, there are two types of things in the world. There are those things which exist from a third-person perspective, can be understood objectively. And then there are those objects, and we don't know exactly how many of them there are in the world, which also have interiority, a first-person dimension, a sense of I or something, an agency, right? And that's a different type of thing altogether, right? The trouble with a strong dualist position is it really brings an end to a scientific study of the world. So I've tried to be a naturalist and extend the possibility of natural study of the world as far as one can possibly go. So to include the social sciences, those areas which study the human being, within or under that umbrella, right? The only way to do that is to find a series of stages along the way where the world is constantly becoming new or novel. And to emphasize the continuity of these steps and to de-emphasize what appears from personal experience and introspection to be a radical break between all those third-person things, right? But I do think that primatology, just to name one example, has pulled us away from that Cartesian view that they're all machines out there until you get to race cogitans. And then all of a sudden, boom, you've got a soul or a ratio at work. It seems to me now the steps are becoming smaller and smaller. That in fact I am, and one is justified in, seeing the human being as involving the kinds of biological processes that we see in other complex organisms, and especially in the higher primates. Right? If I said, the world's pretty much in a continuity, and then boom, there's this interior dimension, you would have a break. The area of study that I find in biology particularly fascinating, if we were going to do this in detail, is biosemiotics. It's the attempt to look at semiotic relationships, which are relationships of meaning, and interpreters, well down the evolutionary scale. If that's right, then you have a sort of subjectivity at work at much earlier levels. Another empirical result is the demonstration of culture in further and further down the hierarchy, clearly in the apes, but now we're finding what look like cultural manifestations in bird species as well. All of those are arguments to see this break from the third to the first person as not so radical as it has been traditionally painted.
Do you want to come back, Patrick, or should we?
No.
No, you'll leave it one. That's a long discussion,
Yeah.
a very interesting one. Another question? Yes.
So I was interested to hear these kind of emergence stories, and I realized today that I was wondering what kind of emergence you would talk about, and I realized that I'm actually an emergenceist, whatever that is. So I originally coming from a theoretical physics background, now working in chemistry and biology. And what I wonder, what's the difference between this emergence and what we would call the idea of coarse graining? So let me give you a very simple example. My organic chemistry colleagues have a whole kind of language of polar bonds, aromaticity, etc., that they use very happily to do their organic chemistry. And they always complain that we want them, as theorists, want them to do quantum mechanics. And by and large, they can very happily and very successfully do their science without any knowledge of quantum mechanics at all. They have a set of rules and they work pretty well. But occasionally, we can point out that one of their concepts is actually, it's a coarse-grained idea, okay, but sometimes it's not quite right, and that's perhaps where we have some limited value to them. But the point of the coarse graining, and I wanted to know the difference between coarse graining and emergence, is this. When I coarse grain, what I'm doing is I'm looking at a chemical system, I squint my eyes and say, well, there's so much quantum mechanical detail there. I don't care about all of that. All I care about is some kind of effective parameters. And I can, in many cases, very carefully derive those. In other cases, I can't yet. But it's not so hard to see that one day I will be. Will. And so what's the difference between that and the idea of emergence? And I think one more thing. I think Laughlin is the particularly bad example. I think he's not particularly he's very highly thought of as a scientist, but I think this stuff he's been saying recently on emergence hasn't gone down very well in the physics community.
Partly because he's insulting the physics community right and left at every possible opportunity.
He has a well-developed sense of self-esteem, and and I think probably it's hard that what people don't like about it is that they don't see the difference between something fundamental in emergence and just saying this is coarse graining. I don't think any of the examples, fractional quantum Hall effect, anyons, all that is just coarse graining concepts. I think that's all it's usually doing. So I don't really see what's fundamentally different about it.
Good. It's a good question. The coarse graining, fine graining distinction can be, could be supporting either position. So you might say, and you said at one point, if I sort of squint my eyes, right, then I can see some approximations that work at a certain level, say biochemical bonds. But if I really looked carefully, I'd recognize that they're really application instances of more fundamental laws. And that was the position that would be an opposed position to an emergentist position, right? Because if it involved the claim that eventually or finally we'll find out that what biochemistry is really is nothing more than the manifestation at a rather complex level of very fine, say, microphysical causes or quantum principles, then you would have an anti-emergentist position. And those of us on the emergent side of the fence are wagering, that that's finally an inaccurate picture. And we think that there's evidence already in the world that there are levels which aren't just a matter of not looking carefully enough, but that the world actually breaks down into different levels at which things are manifested. And of course, as scientists, we're thrilled when one can find the sort of connection effects. But when the quantum physicist can occasionally show quantum effects in biochemistry, it doesn't follow that biochemistry is nothing more than those quantum effects. When those claims are made, and they are made in the literature, those are, it seems to me, statements of faith.
Yes, question over here.
Philip, thank you very much. That was a very rich and fascinating paper. If I could just come back to one little point you made about the first person, come back to the first person. Philosophers of religion often use the question of consciousness in relation to fine-tuning items and whatever. But they often use a rather thin sense of consciousness, it seems to me. I mean, specific conscious states, this sort of sense data that I'm experiencing in any particular moment, and how can you explain that scientifically? But it seems to me too thin, because the real issue is not as it were these specific states of consciousness, but self-consciousness in its rich form. I mean crudely, Milton's Paradise Lost or Dante's Commedia, that is what's entirely lacking at the animal level. I mean, if you were to want to define, a really strong difference between human beings and animals, it seems to me that's in the imagination, but not in some thin sense of some whatever very basic mental operations, but as the realm of the imagination, that rich, spiritual.
Lovely question. I'd like you to take the last two questions and place them side by side. So Douglas's question saying, and actually the preceding him, the question, what's his name?
Patrick.
Patrick's question from before, right? Those push the emergentists to say, you haven't gone far enough. You haven't done justice to this much more robust mental entity, right? This question, by contrast, says, you've gone too far. You haven't recognized the extent to which we already can do reductions of one level to another level in terms of explanatory power. And it seems to me the best, now if we're going to do sort of philosophy of nature, we're going to ask, what's the best overall understanding of the natural world? That in between this view, which it seems to me doesn't adequately grant the difference between the levels, and this view, which seeks to make them too sharply distinguished, is a very attractive natural philosophy, if I may, which does neither of the two. And I don't have time to do it in detail, I hope we can pursue it, but the way in which I'd approach your question would be to look at the levels, the gradual levels of emergence, the sort of thing that you're really interested in. Thick, deep imagination. Imagination which can jump in an instant, 8 light minutes to the sun, that can jump over millennia of time in an instant, and which can imagine the nature of the divine, right? Those seem to be qualitatively different types of properties. But if we look at the whole scale of emergence of complex life, it seems to me we find increasing mental capacities, right? Leading to richer and richer variants, and within humans, over the course of time, increasingly rich cultural heritage and ability to do art and things and so forth. It seems to me that then we can begin to tell an explanatory story which is non-reductive and yet recognizes that process of continuity as well as the discontinuity that you emphasize.
Well, I think that's a great moment on which to finish. I'm sure Philip will be able to stay around afterwards and carry on this discussion. Thanks for everybody for coming, but especially thanks to Philip again for a great talk and a very stimulating discussion. Thank you.
Thank you, David.